see if we can visualize the chain rule for this horrible case that I just made up. Which is actually not totally unrealistic, right? So we have a function f that's of x, y, and z. We have x, y, and z that are parameterized by two variables, right? S and t. And then I noticed later, hey, maybe I want to convert to polar. So s and t are functions of r and theta. You guys see that? This is really totally a thing that could happen. Right? I'd have a parametric for my x, y, and z. And then I've got some conversion I want to do later. So I want to know, how could I construct that nice picture that tells me how to chain rule stuff?
R theta, R theta, R theta, R theta, R theta.
Okay, so what do? You take f, and then what?
Then like 3 branches.
Okay, f depends on
3 functions.
x, y, and z, right?
But x and y can cross each other since they all cross.
Yeah, you just go down to x, y, and z.
Okay, so these need to go to x,
Y.
y, and z.
All 3 of those go to s and t.
So you have the partial of that with
Okay.
respect to x.
So hang
down
on.
the line.
Then there's s and t, and all 3 of these branch.
And s and t branch to r and theta.
Okay, and then s and t, there's an r and a theta. And s goes down this way, and t goes.
Now we're summoning the Antichrist.
Yeah.
Yeah, okay. We're summoning something horrible.
This looks like some kind of weird
Voodoo. Yeah, we're summoning the math gods. All right, so how do you do this again? Like, say I want the. Is it a partial?
You have to trace out every.
I want to do f with respect to r. Is it a partial or are they hard derivatives?
This is going to be partials.
Partials, right?
Yeah.
Okay, so I want the partial of f with respect to r.
You're gonna
It's
have
the sum
to-
of every line.
Okay, so
You're going to have a d.
let's see. These are partials with respect to x's, right? Partial with respect to x, partial with respect to y, partial with respect to z, right?
Yes.
And then these guys are
Partial of x
Partial
with
of
respect
x.
to s.
partial of x with respect to s,
Partial.
partial
x
of
with respect to t.
x with respect to t.
The other's not.
Okay, and I'm not going to fill the rest in, right?
Yeah.
So what do I need? I need to find the paths to r, right?
Yeah.
Okay, so there's a path to r.
One of them.
What do I write the blue path down as?
Oh god. Okay. Partial of f time over respect to it.
That's partial of f with respect to x,
Multiplied by partial of x with respect to s.
partial of x with respect to s.
Multiplied by partial of s with respect to r.
Perfect. Nice.
So it's partial of that.
Okay, so if I thought about canceling, right, I get the partial of f with respect to r. That's good.
And
Now,
you
what do
the
I
same-
do?
You do the same for the other 3 variables. 3 parts.
Okay, so there's, oops, that's a
Partial of
marker.
f with respect
We
to
have to take
y.
every path to R, right?
Okay, so there's another path to r that's the green path, right? Oh,
You could also
you want to
do
do the
x,
x
y,
one
and t.
first?
It's like easier to track that way.
Yeah, I think that's good. Okay, so let's do the x ones first. So if I want to do the other x one, how else could I get to r?
Go to x, go to t.
Okay, I could go to x, then go to t, then go back to r.
Oh boy.
Okay, so that's going to be what?
Oh, there's another path.
partial of f with respect to x,
Partial of f with respect to x.
partial of x with respect to t,
Good.
and partial of t with respect to r.
Perfect.
Do we get
Is there another
And then what do I do in between these?
Plus.
Add
I
them.
need to add them. Okay. And then what's the next one?
So we
Y.
get
Yeah,
two-
choose the y path.
Okay, so I gotta chase a y path. So if I go to y first, how can I get to r?
I'm starting to see
You
a
have
list.
S or T.
Either s or t, right? So there's a s path there. So the red would be partial of f with respect to y times the partial of y with respect to s times the partial of s with respect to r. What do I want to add that to?
With respect to y, times the partial of y, with respect to t, partial with respect to r.
Cool. F with respect to y times y with respect to t times t with respect to s. Good. That's the other y path, right? Oh, r. Thank you.
Then two more for the Z.
Then there's two more for the z, right? But they're exactly the same thing, just with z's for the front variable. So I've got partial with respect to f of z. Wow. Partial of f with respect to z times the partial of z with respect to s times the partial of s with respect to r plus, and the last one, finally. Okay, we're bored. Good. Partial of f with respect to z times the partial of z with respect to t times the partial of t with respect to r. Good.
And then it does it all over again, only all with betas.
Perfect. Yeah, so this is the r partial. And then theta partial's the same crap with all the r's turned into fantasy.
Yeah.
Yay, chain rule.
Cool. This is much better, actually. This diagram thing is really nice.
Yeah.
Can you imagine doing
Keep
this
track of
without the
it.
diagram? You just have to write down the dependencies and make sure you got all of them. It's horrible.
Yeah, try to chain rule in your head.
I learned this diagram from your textbook. I like this thing. Any other questions, concerns, Steels?